To solve question 1 of Unit 2, 2025 PR Math. So the first part says, find the equation of the tangent to the curve, whose equation is x to the 4 minus 2xy plus 3y squared equals 0 at the point minus 2, 2. One thing I just want to mention before we start this is that point is actually not on the curve. So this equation kind of doesn't make sense from that perspective. It's like if I told you, find the equation of a circle at a point that's not on the circle, of the tangent to the circle, at a point that's not on the circle, it really doesn't make too much sense. But basically, they have a procedure. They just want you to follow the procedure for this and just see what you get. So let's go through the procedure. First thing is, let's write the equation. X to the 4 minus 2xy plus 3y squared is equal to 0. I have to differentiate with respect to x. And remember, now I'm going to use implicit differentiation. So that means whenever I see a y, when I differentiate it, I have to just differentiate it and then multiply by dy dx, right? So the first term will be 4x cubed. And then here I have to use the product rule. So first, if I have to differentiate x, that just becomes 1, so minus 2y. And then minus 2x, and when I differentiate y, I just get dy dx. And then it's plus 3y, so it'll be plus 6y times dy dx, and then 0. So now I just solve for dy dx. 4x cubed minus 2y minus dy dx times 2x minus 6y equals 0. So dy dx is equal to 4x cubed minus 2y over 2x minus 6y. And remember, x is equal to minus 2 and y is equal to 2. So then dy dx will be 4, then minus 2 cubed minus 2 times 2 over 2 times minus 2 minus 6 times 2. If you calculate this, will be minus 36 over minus 16, which is just 9 over 4. And the tangent, therefore, it passes through the point, so it passes through minus 2, 2 with gradient 9 over 4. So you just find the equation of the line now. So you could use y minus y1, so y minus 2 is m, 9 over 4, x minus x1, which would just be x plus 2. So then y is equal to 9 over 4x plus 9 over 2 plus 2, which is 9 over 4x plus 13 over 2. That's to find the square root of 2 minus 3i. So the way you do that is you set up, okay, well, if a plus bi is the square root of 2 minus 3i, well then a plus bi squared is equal to 2 minus 3i. Now if I expand this brackets, I'm going to get a squared plus 2abi plus bi squared is equal to 2 minus 3i. But remember, I squared is minus 1, right? So I could say instead a squared plus 2abi minus b squared equals 2 minus 3i. So now what I do is I equate the real and the imaginary parts. So the real part is a squared minus b squared on the left side, and that has to equal the real part on the right side, so that's 2. And then the imaginary part is 2ab must equal minus 3. Keep in mind a and b are real numbers here, okay? Okay, so the first thing now, I'm just going to solve for a and b simultaneously using 1 and 2. Okay, so the first thing is, okay, well, b is equal to minus 3 over 2a. And now if I sub into 1, a squared minus 3 over 2a squared equal 2. And then that's going to be a squared minus 9 over 4a squared is equal to 2. And then if I multiply by a squared, I get a to the 4 minus 2a squared minus 9 over 4 equals 0. So it's a quadratic in a squared. You could just solve it, like, let y equal a squared. So I got y squared minus 2y minus 9 over 4 equals 0. And then if you use the quadratic formula, the solution is minus 0.8 and 2.803. And remember, y is a squared, so you could just say, oh, a squared is minus 0.8 and then 2.803. But no, remember, a is a real number. So this one has to be discarded because no real number could be squared to give a negative number. So then a squared is equal to 2.803. So then a is just the square root of that, which is now plus or minus 1.674. And then b, remember, it's minus 3 over 2a. Oh, over 2a, like that. So now it'll just be minus plus 0.896. So to write the answer, there are two answers. The answers are 1.674 minus 0.896i, And then the other answer is minus 1.674 plus 0.896i. In general, when you're finding the square root of a complex number, the answer will always be like plus something and then minus something. You see how the second answer is just minus the first answer, just like how for the square root of a real number, the answer is always plus or minus something. Well, the answer here is really, I guess you can think of it as plus or minus 1.674 minus 0.896i. Because the plus or minus will square to give 1. You should always get two answers, of course, right? He asks us to find the derivative of sine inverse of e to the x plus a over 3 with respect to x. So, I mean, this is really just using the chain rule, but you have to also remember d dx of sine inverse x. If you remember, it's 1 over the square root of 1 minus x squared. So now d dx of sine inverse e to the x plus a over 3. You need to use the chain rule. So the first thing is just going to be 1 over the square root of 1 minus, but now I see x, I have to put all of this stuff, e to the x plus a over 3 squared, but then by the chain rule I have to multiply by the derivative of the brackets. The derivative of e to the x is just e to the x, so it'll just be e to the x over 3. So if I just put these together, it'll be e to the x over 3 times the square root of 1 minus, in brackets, e to the x plus a over 3 squared. And that's it. So, I mean, this question is the two things you need to remember. One is, what's the derivative of sine inverse x? And then how do I use the chain rule? Okay, this last question, question D, is to find the integral of e to the 2x times cosine x dx. Now, this is like, it's a kind of tricky question, but hopefully you've seen this before, because I mean, like, if you didn't see something like this in the exam, it's actually really difficult, but hopefully you've seen stuff before, like where it's at e to the x and cosine x. What you have to do is you have to use integration by parts twice, and you're going to get back the same thing, because if you think about it, right, when you differentiate e to the x, you get back e to the x, and when you differentiate cos, you get sine, and when you differentiate that again, you get cos. So you'll get back the same thing and be able to solve for the integral. So let me show you exactly what I mean. So let's say I call I equal the integral of e to the 2x times cosine x dx. So I'm going to use integration by parts. So I say, oh, u is e to the 2x, and v, dv is cosine x dx. So then du is 2e to the 2x dx, and then v is minus sine x. So using integration by parts, it's going to be uv, oops, there shouldn't be a minus sign there, it should just be sine x. So it should be sine x times e to the 2x, and then minus integral of v du. So that's minus 2 integral of sine x e to the 2x dx. The first step when you get integration by parts with this trigonometric times the exponential is you'll switch the trig from a cos to a sine or a sine to a cos. The next thing is you do that again with this trig integral. So here I'm going to let u equal e to the 2x, and then dv equal sine x dx. So then du again is 2e to the 2x dx, and v is actually minus cosine x, right? Okay, so it's sine x times e to the 2x minus 2, and now in brackets it's uv, which is minus cosine x times e to the 2x, and then minus v du, so I could put plus 2 integral e to the 2x times cosine x dx. But the beauty is, remember, I is this integral. So this here now is just I. So if I was to simplify all of this, it's going to be sine x times e to the 2x plus 2 cosine x times e to the 2x, and then minus 4i, right? So then that means 5i, if I was to, remember this is all equal to I. So now I'm just going to solve for I by bringing this 4i on that side. So 5i is equal to sine x e to the 2x plus 2 cosine x e to the 2x. But to solve for I, it's going to be sine x e to the 2x plus 2 cosine x e to the 2x over 5. And then the last thing, don't forget to put plus c.